Hi everyone, hope you're all well this morning. Just a little bit about AMP software before we begin. For those that don't know, AMP is an Italian company founded in 2008 by Martino Ierian. That's Martino in the middle of that picture with his arms crossed. With some of the team, we've got I think about 31 or 32 staff now around the world. It's growing all the time, especially now as the reliability of video is getting questioned a lot more by the courts and the legal systems. We have a mission within AMP software to be the one-stop shop for any needs relating to image and video analysis and enhancement. And that is all we do. It is purely for video and image restoration, analysis, and enhancement. And we have a vision of justice through science. And that is, again, something that's very dear to my heart, is that whatever we do, it has to be, my screen has moved automatically. Whatever we do, we have to have some scientific backing and some research. And some knowledge, and be sort of objective in our decision making rather than subjective. Okay, a little bit about me as well, that if you've never come across me before, I started off as a police officer in the UK in the Metropolitan Police in the early 90s, moved to a smaller force in the UK in 96, and then 2003, I started a small CCTV investigation unit, and over the years we developed various things for CCTV and video investigation, and I was lucky enough to work on a national level on a number of projects and a number of cases. But then in 2015, in the closure of that unit, I decided to leave policing and head out into the big wide world, and that's when I started working with AMP software. I also do casework now, and I do a lot more sort of case consultancy and peer review of casework to ensure that video is being investigated correctly and the courts can rely on that information. So today we're going to be looking within one of our products, and that's AMP5. You can see our other solutions there, AMP Replay for cops and first line responders. It's like, it is a video player purely for policing. So it is designed specifically for law enforcement and has some very basic functions, but all simplified as well. So it's ideal for the frontline cops. DVR-Conv standalone conversion tool using the AMP conversion engine 5, which we're going to look at today, the forensic image video enhancement. So that's what it stands for, 5, forensic image video enhancement, not version 5, not number 5. It is that's what it stands for. And lastly, AMP Authenticate for the authentication of images, and also we're now getting the authentication of video in there as well. But video is another minefield, so it's a slow burner. And as you can see on the bottom there, that's the route through the applications: first responders, technicians, analysts. Okay, so I'm going to have a mouthful of my coffee. Very important. And the first stage to then looking at speed and speed analysis is understanding the video. It is key to put across, especially within the legal system, that you understand the data that you're basing your evidence on. And there's 3 stages of initial video analysis: exhibit analysis, data analysis, and then the visual analysis. And once you've done those, that can go a long way into identifying the item's integrity and the item's authenticity. The integrity side, mainly on the sort of exhibit analysis, deals with, has it changed since the time that it was originally created? And this is very important for speed analysis. If you are being presented a video that has changed, it's been transcoded, any changes, it might even gone into a different container, those are changes that may affect your analysis when it comes to the speed, specifically for the timing. So identifying any integrity issues is one of the first stages of the analysis. Then that moves into the authenticity, in that, is it a true and accurate representation of that which it purports to be? So is it that road? Is it that location? Is it that date and time? That's all part of authenticity. But also, is it showing me the scene as it should be? Lens distortion, normal lenses, fisheye lenses, incorrect aspect ratio, that is then an inauthentic view of the scene. So you have to identify the authenticity, not only of the file of is it correct, as in, does it show that location? Does it show that date and time? Does it show the right vehicle, etc., but is the scene authentic in itself? Again, that's one of the sort of key issues that I come across a lot, is that aspect ratio issues haven't been identified, lens distortion hasn't been corrected, and because of that, distance and measurements can be questioned. So there's the three stages of your initial analysis. When it comes to looking at the data analysis, and all this is from AMP5, I've put them into slides just to sort of speed things up a little bit this morning. When it comes to speed analysis, in AMP5, we have the advanced file info. And you can see under the advanced file info, lots of information. The advanced file info is tabbed on the top. You can see that we've got a summary, media info, FF probe. Media info and FF probe will use the same library in order to identify data, but they identify different pieces of data and sometimes will report different data in different ways. So it's a good idea to look at both, but it's using the same library. Then EXIF tool, and we've got some other more advanced analysis tools and analysis tabs here: frame analysis, GOP analysis, and the hex viewer. And I'll look at those in a moment. One of the things you may notice on this file down the bottom here is we've got a frame rate mode, and it's actually been reported as variable. So we've got quite a good system here, and we can actually see that our container frame rate is 15. The container has to have a standard frame rate, especially when audio is involved. And then we've got a minimum frame rate and a maximum frame rate. So we can see that variability in the frame rate. Again, we're going to be looking at this. The most important thing to consider is identifying the timing of the video and the reliability of the timing of the video. The next thing is one of our advanced tools in the advanced file info, and that is the frame analysis. This is just a very, very small part of this data. You can see I've got a scroll bar here. Every single frame of data, so every single sort of frame of video will have data related to it. And this is a table of that data. You can see down the bottom here, I've got an open in Excel, so we can bring that data out into Excel, and then you can do whatever you want with that data, because obviously Excel is huge for data analysis. And again, this will give us various key pieces of information to do with the timing of the video. You can also look at the GOP analysis and see if there's any issues with the GOP. GOP group of pictures. An MPEG video will be structured into groups of pictures. I'm not going to get into the the sort of the nuts and bolts of video encoding here, but you can see these groups of pictures here, and then the frame types. We've got an iframe at the start, and then our predicted frames afterwards. Sometimes a quick view of the GOP analysis can see some issues because one might not be the same length, and if it should be, because all the rest of them are, that might then say that there's a bit of a problem in that GOP. I usually use this as a quick scan to go through. And all of our advanced frame analysis, the GOP, and then the hex viewer are interactive with the visual image. Again, you can then go through, and if there are issues, and there's issues with timing, there's issues in the GOP, or you find a frame that has some slight issue, might have a bit of distortion in it, or it might have an extra length in the frame duration, then you can go through and then you can click that frame in either of those three tabs and then view it in the hex viewer. You can actually then view it in the frame analysis, and you can then view that visual frame. So it's all interactive and linked between the visual image, the GOP structure, and the advanced frame analysis and the hex viewer, which makes the initial analysis stage so much easier. Remember, I was saying is that we can take our data out into the Excel, the advanced frame analysis data out into Excel. Well, then this is one of the things that you can then do in Excel. And you can see here that I've got my GOP analysis, which is here. I can see that that's an iframe and that's an iframe. And then these are all the timing data. This is all the timing data with the duration of the frame. So I can see that we've got a longer duration on the frame here, longer duration on the frame here, etc., etc., etc. And you may notice that we've got a pattern. So we've got a long duration, short, short, long. And then there's a change at this point here. We've only got one short duration on this frame type. And then it carries on again, 2, 1, 2, 1. But then the pattern has changed of where my iframe is. We've got, a short, long. And then it's different here. Something happened here. And if that is in your range of frames where your speed analysis is going to be, that might have some effect. It's a may. But identifying these things are so important to show that you understand the video data that you're basing your initial analysis on. Timing. We've talked a lot about timing already. There's 3 methods of identifying timing on video. The first one is the presentation timestamp, and that's with MPEG video, and probably 70% of the video that is getting recorded by surveillance systems and consumer recording equipment will have is being recorded in using MPEG type video. And that will have a presentation timestamp. That's how it controls the timing of those frames, because as you've seen, it can use variability. And the presentation timestamp can give us that information of where give us the information of the variability of that timing. The next one is the container frame rate. The container frame rate you've probably seen many, many times, and that is, this video has 15 frames per second, like we saw in the advanced file info at a container frame rate. It's not exactly 15 frames per second. There is some variability there. And even in other types of video that isn't MPEG, you may have a little bit of a change. 1 second may only have 14 frames per second. 1 second may have 16 frames per second. But it's just been averaged out. A lot of the time, you'll see that on transcodes. You'll see that, the original video may have had some variability, but then it's been transcoded, and the transcoding has lost all the variability, and it's then becomes standardized. That can be quite important to identify. The next one and the last one is average, and that is the number of frames divided by the time. And so that can be slightly less than the container frame rate or slightly more than the container frame rate, depending on how it is. But there's the three methods of the timing. And we'll talk a little bit more about that in a little while. In 5, you can see that we've got various playback modes. And so you can actually decide how you want to play back the video according to whatever information you have. You can see here that I've got average frames per second playback selected. We've also got PTS-based playback. So if our file does have PTS, presentation timestamp from the MPEG, when we can use that. We also have the timestamp-based playback. And the timestamp will be over the top of the video or can be extracted using the AMP conversion engine as a .time file. And then we can use that .time file in order to play back the video. Now, here's a quick presentation that I put together yesterday specifically for this webinar, actually. I'm just going to grab another mouthful of coffee here. This short presentation of me identifying some of the important information that I need took about 10 minutes in AMP5. When you're wanting to display and analyze and present certain pieces of key information, AMP5's presentation tools now are so good for doing things like this. So you can see I've got in my text box there, in my annotation text box, I've got original position in frames. So you can see that's the next frame, 513, 514. And you can also see my PTS duration down the bottom here. So we're looking at a frame here that has a duration of 75 milliseconds. And we can see the frame type P predicted. And you can see in my box out here, my overlay, I've got macro blocks. My brain stopped working there for a couple of seconds. We can see my macro block analysis. And there's not a lot going on. Everything's gray there because these are just copied blocks. There's a little bit of movement. Now, we've got some changes coming on, and you can also see I've added on another graphic at the top. And this is then the first frame showing 29 in the seconds. So we can then count those if we were going to be using the clock over the top of our video for timing. So you can see that is the 5th frame. I just move my mouse here. There we go. That is the 5th frame showing 29. So we're going to have a counter over this. And you can see in my macro block analysis, we've got our vehicle going in for our frames. And we can see in our text box, we've got the frame duration and we've got the original frame number. So this is frame 532 from the file that we are investigating. Now, the macro block analysis is very important to us. Again, it's a lot to basically say that, you know, we have analyzed the video and the information that we are using is reliable. If I just go to one of the frames here, oh, that's the last iframe, we can see that we've got our arrows, which is our motion vectors. So we can see where our blocks are coming from. When you get highly compressed video, the blocks are might be predicted a lot more than what they are here. I can see that I've got a lot of purple blocks here and red blocks over my vehicle. So this is a lot of new information. And this new information is a lot more reliable to me than predicted. Prediction is still reliable, but I would have to then do some further analysis on it to see the blocks, because what I'm looking for is the reliability of where the bottom of the tire hits the tarmac, hits where the road is, because this is the plane that we're going to be using for speed analysis. So I need to look at this point here. So how reliable is that imagery? And again, when we're using very highly compressed data, or the vehicle is further away from the camera, the reliability of that piece of data may be reduced. So I'm going to have to use a bigger uncertainty in the area that I'm selecting of where the tire hits the floor. And you'll see that in a moment. So we can see that we've got up here, yeah, we've got 15 frames showing 29. It's 15 frames per second video, so that's right. However, sometimes that might only show you 14 showing that time, or 16 showing that time. The frame rate might be 15 frames per second. It may have a variable frame rate because it's using presentation timestamp to control the timing of the video. So all of these things are pieces of information that I'm going to take on board so I can understand the reliability of the information that I'm being presented in the video. And there's the next intra frame there. We've looked a lot there about reliability of the information. We've looked a lot there about timing and the timing of the video, because we're going to take that on board. The next thing we need to figure out is measurement. Now, we've been doing measurement for quite some time in AMP5, and the Measure 3D tool, which uses single view metrology, is something that has been tried and tested for probably 15, 20 years in the courts. And it is a very, very sort of forensically rigorous way of identifying and establishing a height range of a suspect in a piece of video. Well, we can use that methodology, and we can use some of that measurement in measurement tools, not only to establish height, but to measure distance on a plane. And if we put all that together, then on incidents like that, because we've got a good camera view, so this is the first thing, the camera view covers the vehicle, covers the road. I can see where the tires hit the road, and we can establish some measurements in the road because we need some known measurements. Then we can put all that together, and then we can let the software do all the math. Anyone that knows me will know that math is not my strong point. You know, that is where the software can take all that hard work away from us, and also the presentation side of things. Now, speed analysis is not new. There are many people, I know that there are many people watching this webinar who are much more experienced than me on speed analysis, and that is, you know, in collision investigation. And it can be extremely time consuming, and it also can get extremely technical, especially when we're doing laser scanning and reverse projection and 3D modeling like this. The purpose of speed estimation 2D is really to try and speed up, throwing that word in, is to try and speed up that initial investigation stage. And if you don't need to do certain things because the video does meet certain requirements, then you can do a speed estimation to a very, very high degree of certainty within 20 minutes. And that is the power of the speed estimation 2D filter. And you can see here, you know, we've got one here in one of our tests, which we're going to show something similar to this in a moment. And, you know, very, very quickly identify the vehicle of interest, identify the range, correct the lens distortion, identify the measurements, and then follow the path of the vehicle, and then that will give you the speed. So there's some source material here, which I will try and sort of copy a bit later and then put into the chat. But the SWIG-DE documents, there are two at the top there, and then there are two JFS documents on vehicle speed as well. There may be some others, and if you do know them, please you know, drop it into the chat. If you know of any other open and sort of non-restricted research documents on video timing and speed analysis, then please drop them in. Okay, let's head over to 5. So let's see how we go here. There we are. Now you should be seeing 5. For those that haven't seen, I'm just going to do a quick time check. Okay, yeah, we're doing all right. Quick mouthful of coffee. For those that haven't seen AMP5 before, very, very simple interface. It's, you know, you'll learn it very, very quickly. Your filters up here, your tools here. Half of the tools get selected automatically for you whenever you use a filter that requires a specific tool, so you don't have to think about it. One of the important tools here for when you're working on video timing and video data is the time calculator. Time calculator works in a number of ways. You can either have one time and a known offset, and then you can calculate the end time, or you can have a 2 times, a start time and an end time, and then you can calculate a duration, or the difference between the 2 times. And all of the timing information in 5 within the filters, and also if we had a date and timestamp down here that was being detected from a timestamp file, all of those are copy and pastable. So you can move things around and copy a date and time from one thing and paste it into the time calculator, etc., etc. Again, it just takes away a lot of the headache. I'm not into headaches. I'm not into doing things in a complicated way. Anything for an easy life. So time calculator down here. We've got our viewer here, which is where we see our image, and you can see our viewer is managed with tabs. So if we've got a number of chains, you'll see all the tabs over the top here. And you can move those around, so you can have multiple screens open and multiple viewers open at the same time. We've got our player panel here. Our player panel is interactive, and you can see the information that's down here will change depending on where you are in the filter chain. So because I'm at the speed estimation 2D filter here, then we can see that information over that range of frames within the player panel. If I was, I think if I go, I think there's some audio on this one. Yes, we can. There we go. Because you can see here, I've gone up to the video loader in our history over here, and now I can see the audio. So that will change depending on where you are in the filter chain and what needs to be what needs to be worked on, whether it's the audio or annotation or speed. Again, happens automatically, so you don't have to think about it. Just drag that back. There we go. All right. And where were we? Oh yeah, that was it. So this is the history, and you can see that we're working in folders, and we can have multiple folders, multiple chains. You can just copy your videos down. You can move things around. You can copy and paste filters, so you don't have to do things 2 or 3 times. Just move them. Again, it just simplifies your workflow. And up here is your filter setting. So whatever filter you're on, so if we went to our correct fisheye here, whatever filter you are on, you will see the filter parameters within the filter settings. And you can go back up and down in your filter chain. So because I've double clicked my original video here, but I'm going to single click the range selector, the correct fisheye, I've still got my settings here for the video loader. So I can correct and change a filter's parameters and see it at different points in my chain without affecting what I'm viewing. So that's the difference between double click and single click. Again, I'm just putting that in because I was at a training last week and people never realized you could do that. So it's sort of on the top of my mind. So always remember that. If you're a 5 user, you can test it and have a play. Again, a massive help. And you can see the final result of my speed estimation 2D here. You can see that we've got our grid, and I'm going to do all this in a moment practically. We can see our measurements, and I'm going to write those measurements down, otherwise I will forget them. Because I'm going to copy those measurements in a moment. And we can see our speed, and we can see our speed data at the top here. And all that information is calculated for us. One of the things that I often get asked is, well, if I don't know the measurements, and if I've got nothing in the scene to use for the measurements, what can I do? Well, it's exactly the same as for height analysis. You can go back out to the scene, and if there's nothing in the scene to allow us to establish X, Y, and Z axes, then we can put things into the scene. We can do, if the camera hasn't changed and the recording system hasn't changed, very important, we can put something into the scene, and then we can do the measurements from that. And then once we've done the measurements, we can just copy and paste that filter down onto our evidence filter. Onto our evidence chain, where our suspect vehicle is. So here we haven't got anything in the road. So we've got no lines in the road. So I would have gone out with what I call forensic flooring. And this might just be a big sheet of lino flooring. And I know that each one of these perhaps is a meter, each block is a meter. So I know that that is 6 meters by 6 meters, etc., etc. I can do my grid using that. And then I can then just copy and paste my speed estimation 2D filter down onto my piece of evidence. I hope that makes sense. It is a standard superimposition. You can also blend the two together. Again, from a presentation point of view, you can blend the two with the suspect vehicle as well, and your return to scene footage where you've put in your forensic flooring. And you can then use one of the link filters, such as video mixer, to blend those two pieces of video together. You can do that also, and that's no problems at all. And again, here is a macro block analysis like we looked at earlier, establishing some of the data that we've got here. Now, one of the things that I often get asked is, well, what's going on with all these arrows? These arrows are the motion vectors. And this is where each block, the macro block, is being moved or has been moved to. So they show where it was and where it's been moved to. Well, you can see, well, we've got, well, why are there arrows pointing up and why there's some long arrows, etc., etc. This again is how compression really works, is that these gray blocks are just copied. There's been no change here at all. Obviously, if the vehicle was moving, and the blocks haven't changed, then we've got massive problems. And you do see that in some very poor quality video. The wheel here is all newly recorded, apart from the middle bit, because it's all red. Red and purple are newly recorded. I won't go into all the issues of what the difference is between red and purple, but it's all newly recorded. Green is predicted. So there's been some changes to this, and it's been changed in location and luminance and color values, but it hasn't been newly recorded. It's just been changed to fit the scene. Prediction is very, very clever. And it's not, prediction is a bad word. It's more of sort of calculated. And so the change in that value is less than what it would take that if it was newly recorded. And because it's less, then it gets changed rather than newly recorded. That's all it means, but it is reliable. And I can see what's going on here, and I can see that, you know, this is all pretty good data. It's quite a good compression system on this video. So I would look at that. But the key to this is to identify errors, you know, and you do see errors sometimes. And what you'll find then is the vehicle can change length because of how it's positioning and it's moving things around. You can, if you do find errors, the vehicle can change length because it's either missed some blocks or it's added some blocks in. On poorer quality video, that is quite a common issue. All right. Okay, here we are, back to it now. So just a bit of a roundup. We've looked at the initial analysis. We've looked at some of the things that we're going to have to take into consideration, specifically the timing of the video. I've identified that the presentation timestamp on this video is reliable. And I would have done my analysis. I've identified any patterning to the presentation timestamp. So I've identified what I should be seeing visually. And remember those 3 stages. Exhibit analysis for integrity, and then we've got the data analysis and the visual analysis to work for authenticity. Is the timing authentic? And for this case, I would have seen that in the data, and I would be looking at it visually to see if I can see that within the data. So looking at, so I can see it in the imagery. We've understood what's going on. We've done whatever is needed, and we may have done some other chains like I showed you earlier in the presentation of showing a lot of that information as the vehicle is going past with the macro block analysis and the timing, and if there's any date and timestamp. On this video, we haven't got any date and timestamp, and we've got no time file that's been detected within this piece of video. So let's go for it. The first thing we need to do is select our range of frames. Because I can see when a vehicle passes here, so we can see the audio envelope here, I'm just going to click straight on the timeline here. And we've got our vehicle passing. Yes, I know this is a very, very simple, and it's not a high street in central London with 1 million vehicles going past and loads of noise, you know, so it does make it easy for me, but you never know. So I'm just going to choose my range of frames. I think I'm going to start just as the sort of shadowing is coming in there. So I'm going to go select frames and range selector. And I don't need, because the moment I'm on a frame and I select range selector, it sticks that frame number in as the first and last. So you only have to select the one that you're not on. Whatever frame you're on, whether it's the first frame or the last frame, it's there set for you. Again, speed. I'm going to be using that word a lot today. I've got my end frame, so I'm just going to set that. It's done. And that's my range of frames. And our range of frames is now set. Next up is our lens distortion. In reality, I would do both, especially for camera like this. I would do both undistort and correct fisheye, and then I would look at the differences between the two. 90% of the time, you're not going to know whether it is a lens distortion or it's a fisheye lens in a camera. We're doing a lot on, specifically for this, we're doing a lot of research on lens distortion, fisheye lenses, and camera calibration. So, we'll just watch this space. And I'll give you a link to our sort of newsletter, so you can keep an eye on the newsletter and keep an eye on our socials as well. And at the end, I'll put a link up for all of those. Because we're putting out a lot of information and we're doing a lot of research, especially on the lens distortion, because it is a big issue and it does affect measurements because you've got to correct it. So for here, I know that it's a fisheye lens, so because I've already tested it, so that just saves us a little bit of time. So I'm going to go to edit and correct fisheye. And you can see it's already slightly applied. You saw it move very, very slightly. Well, I'm now going to do some lines. And the reason why is because I want to be objective in my decision making. I don't want to say, well, it looked better. I want to say that I have used something in the scene in order to correct it. Again, I could have put something into the scene. I could put some objects into the scene. And for correcting aspect ratio, I might have gone out with a sphere. Remember, and I'm sort of digressing a little bit, but remember, for a sphere in the real world will be a perfect 2D circle in the visual world. So in the 2D world. So if I went out with a sphere, I would want to make sure that I'm getting a perfect circle. So that's the height and the width are exactly the same in my imagery. I haven't gone out with a sphere on this scene, but that is something that I may do. And I may put something in the scene to say, well, okay, that's a straight edge and that's a straight edge. I think what I'm going to use on this one is, I know that these are slightly bent, by the way, because the road has some, is it camber? Is that the right word? You see, I'm probably going to get shouted at by all you collision investigators now, but it's got a slight curve to it. I think it's camber. Anyway, I digress again. Let's put on a line because I know that this is a straight edge. So I'm going to go 1 and 2. If we couldn't see, and this is straight as well, if the finding the edges was really difficult, we could apply a filter to this, like an edge detector filter. We could put our lines on using that, and then we could just disable the edge detection. Again, that's something that we can do when there's not a lot of contrast. So I've put in one line there, and then I'm going to put in another line, and I'm going to use, I can't really see, there is a straight line. Tell you what, I'm going to use the edge of the grass here, just on the curb. I'm zooming in and out. So let me go to that one. Let's go to that one. With my mouse key, scroll wheel, sorry. So I put on a line there and I've put on a line there, and then I'm going to press apply. And now we've got straight. Now, I want to see the lens distortion. So I'm just going to open up my canvas. Something like that. Okay. And in a moment, we can see whether or not we've got that right. And then we can, if not, we can go back and correct it. There's the grid we're going to be using, that grid there. How are we doing on time? Brilliant. Okay. So let's crack on. So we've done our lens distortion. Now we go to speed. So under measure, speed estimation 2D. First thing we need to stick on is our grid. And always start top left. Hold on. Again, if you can change the contrast a little bit on the video to make things easier for you. You can just see the black line that goes off just on the side of the curb there. Okay. I'm now going to add on my measurements and always make sure that you get your real world unit correct. Otherwise, I was doing some training last week and a guy couldn't understand why the vehicle was traveling down the road looking as if it was from Back to the Future, because he calculated 88 miles an hour, which did make some people laugh. But it was all because he had his units selected incorrectly. So we've got a width of 391. No, 442. Oh, why is that? There we go. That's right. Yeah, why did those NAs stay there? Anyway, I'll work on that later. That might be a little bug there. So we've added in now our distance. And sorry, not our distance, our measurements. I just want to change the grid color of that. I'm going to go for a bit of an amped blue. And I'm going to extend and see whether or not that stays. Yes, that is staying right on my central line there. And if I went show rectified image, okay, straight, you can see the camber, straight edge. And we can even get our vehicle coming in, because that's what we're going to be using. We've now put in, I think it's orthographic image, which is basically looking at it from above. I'm just going to turn that off. Okay, I'm happy with my lens distortion. I'm happy with my grid. Just going to move my vehicle back now. And I'm going to turn the grid off because I don't want it to get in the way. I'm now going to do the path of the vehicle. I'm going to mute it because I don't want to hear the audio sample for this area. Now we're going to be selecting the path of the vehicle. Remember, for measure 2D, we have to use the plane, the same plane that the grid is on. We don't have to put the grid directly under the vehicle as long as it's on the same plane. So as long as it's on, it's the same. So you can use another area of the road if that area of the road is all on the same plane. Okay, let's now plot our points. You can, if you've got a number of vehicles, like you're doing some analysis on a number of vehicles that's gone past a number of times, if you're doing some speed runs. So if you're doing a 20-mile-an-hour run, a 30-mile-an-hour run, or a 40-mile-an-hour run under on a protected environment, then you can do run 1, run 2, run 3, etc., etc. So you can add on number of paths. So you can do all of that in one filter if you wanted to. So I'm just going to leave that. Actually, I'll just put in a name. Cool. Okay, show marker points all. Yes, red thickness. Now, pixel uncertainty. This is then, remember when we were doing the block analysis and we're having a look at the compression, is, well, how uncertain am I on where the point I'm selecting for where the tire touches the road? Now, for this one, I'm going to select 4. So I'm anywhere in an 8x8 pixel block. I've got a lot of pixels to play with because it's quite a high resolution video. But I don't know exactly where in that 8x8 block the tire is being selected. So I've added that in as part of my uncertainty, because that is then all going to go over into my calculations. And I want to show the uncertainty boxes as well. I want to visualize where those uncertainty boxes are. So I'm going to then say, well, okay, my first point of where the tire hits the floor is there. That's the point there, but it's anywhere within that box. If I then hit the U key, the video will move forward and I'm ready to then start tracking this vehicle. I'll go quiet when I'm doing this because I'm concentrating. Here we go. See, compression is taking its toll here. So somewhere there, I think. And distance from the camera. So the field of view. How many is that? 1, 2, 3, 4, 5, 6. I think we'll do another one. Do another 2, perhaps. The more, the better. Okay. Yeah, I'm quite happy with that. There's my path. Now, we can see we've got a bit of a pattern. We've got long, short, short, long, short, short, long. Remember the graphic that I showed you earlier in the presentation where we had the bars, and the red bars were the iframes, and then we had, 2 smaller bars and then 1 longer bar, 2 smaller bars, 1 longer bar, and then there was a bit of a hiccup in it, and then it sort of changed a little bit. Okay, well, this is what we're seeing. We're seeing here the PTS duration visually, and we can put all that over the top, and if we've got a bit of time, we might be able to do that. We've only got 15 minutes left. So I might be able to put some other information over the top of this video. But what we're seeing there is the PTS duration. And I can visualize that, and I can put it over the top of the video. And let's see if we can do that a bit later. So I've added on the path. I'm quite happy with that path, and it's pretty straight as the vehicle is traveling on a straight line. So rather than in a while, when we come to establishing speed, rather than us going, okay, well, we need this measurement plus uncertainty, this measurement plus uncertainty, this measurement plus uncertainty, etc., etc., etc. We can say, well, okay, well, let's just go from here to here with the uncertainty and miss out all these little bits of uncertainty, because the vehicle is traveling in a straight line. We would only need to do it accumulative, so path length, exact path length, if the vehicle was sort of on a bend, okay, or turning. But if it's going in a straight line, it's much easier, and and better because you get a lower uncertainty range if you just go from start to finish, but still taking in these points for timing. All right, and talk about timing. Let's now move on to the time component. Remember, I've already established that PTS, you know, I would have identified the PTS, and we would have I'm going to put it over the top at the end. And I'm happy that the PTS is reliable in this case. You can see that we've got a number of drop downs. You can either have frames per second average, you can either have PTS, which we're going to use in this case, or you can have the timestamp. So remember, we had a timestamp on that other piece of video. We may just have that. Well, we can add that in. We can add that information in using the add timestamp filter, and then we can use that to select it, especially if the video had a very incorrect container frame rate, like it's been put into a container frame rate of 25 being generic, but it's actually 15 frames per second. Then we can manage all of that using the add timestamp, the load timestamp, the adjust timestamp filter as well. Yeah, there's a lot that we can sort out. But I'm happy with the PTS. I'm also need to put in a time uncertainty. Now, because I'm happy with the PTS, I have seen that there is some variability, but it's only at sort of 2 milliseconds. So it's only got, you know, a little bit of variability there. So I'm going to put in a 2 millisecond time uncertainty. You may find that there is a little, on a specific part, there is a little bit of clock drift. You may find that there is even a missing skipped frame. I think on the one, I haven't looked at it properly, but I think on the one that I showed you earlier, there's a little bit of a hiccup at a certain point. And I think that's probably a drop frame. And these things do happen, and you can identify them and you can account for them in your uncertainty. So we've done that, as we've added in time uncertainty of 2 milliseconds. Next up comes the speed. And I'm now going to just zoom out because it's going to put it over the top, and I'm going to click on new measurement. Straight away, we get some information up, and I'm just going to drag this up the top here. And I'm going to click in it so we're in sort of edit mode. And you can see all the measurements. Now, I want to say distance unit, let's say centimeters. Time unit, I'm going to say milliseconds. Speed unit, I'm going to say miles per hour, because I understand miles per hour. And I'm also going to change the data that I'm showing. And here is all the macros that you can use. And so you can see you've got path length, minimal distance from start frame, minimal distance from start frame, intervals, path length from start frame, time from start frame. There's every single one there. And again, for you collision investigators, if there's another calculation that you need using this data that we haven't accounted for here, then please let us know, because all of these things and this entire filter has been built for you and by you. You know, we are, you know, we've talked to a number of collision investigators, and you've really helped us in building this filter and helped us to help you. So I'm going to put in, rather than start speed from start frame path length plus or minus uncertainty, I'm going to go speed from start frame minimal distance plus or minus uncertainty. And I'm also going to add in speed from, well, no, let's say distance from previous frame plus or minus uncertainty, and time from previous frame plus or minus uncertainty. I think we'll add that, do those. Okay. Let's do that. Okay. So now we've got, so our first one that comes up, and we've got uncertainty 30. So we've got a speed 30 miles an hour plus or minus 3, and then path length, and then speed from start frame minimal distance plus or minus 3, because we've only taken the first frame so far. We've only got one calculation, and you can see as the vehicle moves forward, we're increasing our uncertainty. Should be yes on the path length, because we're adding in all the uncertainties of time and pixel placement. Well, if we only take on that one and that one under minimal distance, that's the reason why that then reduces and that increases. And you can see our distance and time over the top. So we've got 31 miles an hour at the end there, 30, 30, plus or minus 2, etc., etc. Remember I said that we can put on some other data. I'm just checking the time, 5 minutes. Well, we can also do a ruler. So if there's something else in the scene, we may have done an overlay. We may have put something into the scene, for measurements. Well, we can do that, within the scene. So we can check that. We can validate our measurements using a known object. And perhaps that might be an object that you've gone back out and placed into the scene, and then another person has done. So another person can validate your work. Remember bias, don't know distances beforehand and times and things, because then you're going to be biased. Bias is a very big thing, so you need to be aware of that. So you can manage that within your unit. And then we've got export, and we can export all of this information out to an Excel spreadsheet. And here is an Excel spreadsheet with all of that data in. So all of our times and all of our distance and measurements. You can see here the time, the milliseconds, because that's our PTS that we're going to put on. And because we've got that as data, and we've got that as usable data, we can then do graphs similar to this one. So then we can take our minimal distance, distance speed, our maximum speed, and when we can take our average speed as well over the frames that we've selected. You can see here 29.8, 29.7, 29.7, 30.02, etc., etc., etc. And you can present that data, any way that you want. Minimize that down. Back to 5. One last thing. Look at this. All right. Okay. Let's add on. We could put on the macro blocks now as a picture-in-picture, and we could do. This will be death by live presentation now as I do this. So I'm just going to save the project, presentation, annotate, text there. And we're going to put in file name, no path. Just going to sort that out. And put that there because it's a big file name. And then we'll put in PTS time, PTS duration, frame number, original position in frames. So that's not the range, that's the original frame number from the original video. And then frame type. Let's do that. Yeah. Okay. Oh, let's just do a background. That's better. A bit of padding. Get a bit bigger. Yeah. Okay. And then stick that there. Okay. Let's save button again. So now we've got, need to put it on all frames, don't we? Set for all frames. That's better. So now we've got all of our information. How are we doing? Oh, 20 seconds left. All of our information. I would need to, this is a very big 2,600 pixels across. So I would need to, if I was doing this for a presentation, I'd work on some stuff and some resizing afterwards. But that's the reason why one text is slightly different, because I'm zoomed in on one and not on another. But anyway, there we go. We've got all of our information. We've got our file name. We've got our PTS time. We've got our PTS duration. We've got our position in frames. We've got our frame type. We've got our speed, uncertainty with the path length. We've got our speed with uncertainty for the minimal distance. We've got the distances, and it's all ready to go. Speed estimation 2D in AMP5 done. Quick mouthful of coffee. Bang on, look at that, eh? As you can see, you know, and that took what, 20, 25 minutes. When in exactly the same as height estimation, is that if you've got certain parameters and you can identify those parameters and you can rely on that data, it's now much easier to put together and the presentation and establish all the data that you need very, very quickly to identify, that vehicle was doing, that speed range. The cruise control on that vehicle was set to 30 miles an hour, and in all the testing that has been completed, this has been accurate. In all and I would ask you, if you're out there and you're part of the collision investigation community and you've got any data that can be used, or you can put up some data and you can go and do some testing, please do so. Please let us know, and we want to work with you to make this better. And let us know if we've got it, it's accurate, or if there's any problems that we haven't identified yet. We've had 3 or 4 collision investigation units, and they've all come back to say that so far this is all bang on, and there's no issues. But please let us know. Same for timing information, especially when you're looking at timing information. The one I showed earlier in the presentation, we had a variable frame rate, but there was no pattern to it. But again, the PTS was reliable. You can actually see that, and within the motion, within the scene, slightly longer, slightly less, etc., etc. And this one, we've got a pattern, again, reliable. So please let us know if you do any tests and you find any issues. Frame drop and frame skipping is one of the issues that you may come across, and like you can see that usually somewhere in the data, and you can identify that. But that's one thing that video systems, do suffer with frame drop, and then also timing delay and clock drift. That's one of the things that you do come across, but you can usually identify that again within the data. Okay, there we are. Let's see. Oh, sorry if I keep banging on microphone. Let's see if there's anything in the chat. I hope you all enjoyed that. Thank you we had like 17 participants. That's pretty good. I don't know. Let me just drag my chat off of the screen. So, hi everyone. Yes, I have said hi. So, brilliant. So, if you have got access and you can see the chat, it's there's two links within the chat, and they are two blog posts. One was the initial release of the filter, so it goes into it, briefly, and then there's a more sort of full workflow post on it as well. Those two links are on the chat that have been posted there by Michelle, so you can access those two pages. Thank you, Andrew. Andrew's just commented on the chat. For those people who can't see it, it was a very good session, Spready, another great tool for our toolbox. And yeah, that's it. And I think, thank you, Andrew. You sparked a point there, is that, yeah, this is it, is the toolbox, is that what have you got in your toolbox? 5 now is a huge multi-tool. It is your Leatherman, is your 100-piece Swiss Army knife, and this is one of the tools. And when you've got all that data and you've got all that information and you've got ways of dealing with that now, in 5 you can do a lot very, very quickly, and again present that information out in a very, very clear and understandable way. Is that, this is what we've done, this is what we've identified, and these are the results. Very, very quick and simple. And Michelle has added on, yes, we do have a module. We do have a training module specifically on speed estimation. It's a 3-day training course, and it specifically looks at speed estimation. So all the things that we've looked at here for the last sort of hour or so all get put in, and you have lots of hands-on doing different things. Gives you a chance to have a look at all the undistortion and fisheye and comparing the differences between the two, macro block analysis, timing analysis, dealing with all the data in Excel. All of those things are all in the 3-day training module for speed estimation. There is also a 3-day module, just as I think about it, on a presentation, where you deal with all the annotation techniques and presentation tools. And I think those two modules together do give you, especially if you've done the initial 5 training, those two modules together do give you a very, very good leg up in preparing all of this, especially when you're using picture-in-picture with the macro blocks and other date and time information, perhaps, doing, magnified box outs on the date and the overlay of the date and time. There's so many things that you can do now that those two modules will really help you. Oh, we got a question. I think we put, as you already know, a video analysis lab can choose to have an accreditation. Yes. Oh, yes. Well, don't we know it? How can the scientific method behind this filter be presented for purpose? Same question for the other field. Also, can you provide an assistance for those laboratories to establish these methods regarding 5 filters? Wow, Osama, that is a huge question. Basically, what you're saying is that, yes, you need to accredit everything that you do. I will say, this is a personal thing, 17025 has been more of a hindrance than a help. I was told recently by a lab manager that what they identified is that they can actually write anything into their standard operating procedures. It's as long as they follow that anything, then they're correct. Whether or not that's actually right, it doesn't matter, as long as they follow their own SOPs, their standard operating procedures. But everything that you see in 5 will have a scientific reference. The things that we've got here, and what we've got here is a number of different things. Firstly is the analysis of video is just the analysis of the data that is in the video. It's not science. It's just that we've wrapped everything up. The science part first comes into this when we're talking about undistort and correct fisheye. Then you will have, so if I go to correct fisheye, it's a good question. So thank you, Fabio, for your comments. The first thing is that correct fisheye, if I go to help, you can see the scientific references for correcting fisheye are at the bottom, and they're also in your report. Bear with me, Fabio, and I will answer your question in a moment. So the scientific references for correcting fisheye will be in your report under the use of fisheye, and they're also in the help file. So we've got something to relate back to. The next thing under speed estimation is the ability to then correct an image. The ability to correct an image is under perspective correction. And that is under the, if I go to measure, so if I put it onto this one, and then I went measure 2D. Okay. Oh, look at this, death by live presentation. The one, I will mark this down as a sort of to fix, is the adding in the sort of scientific references for correcting an image for the reality. So that is the perspective. So creating the orthographic image. Remember when we did speed estimation? And then under the grid, we can view rectified image. Well, that's an image processing function. And again, it's been done for 30, 40 years, and probably more than that, to be honest. Let me just turn that off. Okay. So again, that's a scientific function. Once you've done that, it's math to say that that amount of pixels is that amount of distance. And because we have time, it goes from there to there. So, but I really get what you're saying. And I think the one thing that we do need to add in, I completely accept that, is we just need to add in the image measurement side of the science. And from there, it's all math. So that's how you would write it. And then you would then validate this filter within your unit by having it in a controlled environment like an airfield, and then having a vehicle go down at 20, 30, 40 miles an hour, doing all of these tests, and then saying, yes, accurate, 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 that you've then got a known. So, and because you've got a known, you can then say, yes, this is a correct, it's valid, it gives us the correct time, etc., etc. And you need to, in order to validate something, you need to have a known, and you need to create that unbiased and in a controlled environment. I hope that helps. One last thing was also, can you provide assistance for those labs to establish these methods regarding 5 filters? Yeah, every unit that is going through ISO accreditation will validate specific filters for their needs. They usually only validate about 6 or to 10 filters, the usual ones, the very, very common ones. Everything else can then be out of scope and can be used as and when necessary, as long as you then self-validate per case. So, you know, has it changed this? Has it changed that? Yes. And because of the way that 5 works, you're keeping that chain. And it is repeatable, it's reproducible, and it's explainable. Again, ISO 17025 doesn't actually deal with science. It's not a science thing. We deal with science, and that is, as I said, it's repeatable, reproducible, and explainable. But I accept that ISO standards have complicated matters a great deal. Anyway, okay. Very interesting. Thank you. Can I export frame and report on PDF file? Yes, I can go out to, I can export all of these frames as images, and then I can use file. Well, we're going over now, sorry. Oh no, we've got a few minutes left. I can go to export PDF. So I can export a PDF sequence at whatever pixel resolution that I've chosen. So I can export a PDF image sequence, and I can export all of my data. So, so I can export my report, because all this goes out to project and generate report, and I can export a report as a PDF as well. And if I wanted to export all of my data, it's too much really to sort of go out to a PDF, but you can go out to CSV, you know, you can go out to one of those, and then you can grab some of that information and go out to a PDF. But there's a lot of data there. That's a lot of information. I mean, it's you know, it's all here. It's much easier to select the data that you want, you know, and then put that to a PDF, in my opinion. But so, and for the frame analysis, PDF frame analysis Excel, again, frame analysis is huge, and that would, you know, again, it's easier to go out to a spreadsheet on that. Okay, I hope that helps. The link about adjust timestamp filter was sent just to panelists and hosts. Oh, right. Oh, okay. Thank you, Martina. Yes. So if you can resend that, that'd be brilliant. Thank you. And there we go. It's now in, so everyone should see that. Thank you very much for your time this morning. It's been great. I always enjoyed doing these, and I always learn as well. Every single time I do these, I find things that we need to work on. We're all here as a team. We as a team at AMPT, you know that we are all a team together with you guys, the users and the people out there doing the work in law enforcement video labs, and then also in private video labs, and for you guys in private collision investigation units. You know, we're all in it together, and we've all got to help each other out. If you can help us out in testing the software, using the software, finding issues that you need, finding problems as well, you know, we all get problems, you know, that's what software development is all about. Finding those things, feeding it back to us, we help you, and in the same time, we then help everyone else out, and so the community benefits. And that's what it's all about.